Hello all. So now I'll be discussing the bias variance trade-off. So in last lecture, what we discussed about the ensemble methods, when we discussed, I introduced a term called high bias and variance. So what bias and variance actually are, let's discuss that thing first. So firstly, let me recap a little bit about the machine learning algorithm. So for any sorry, for any supervised machine learning algorithm, the ultimate goal is to best estimate our mapping function, right? For the given input x, or we can say that for given input training data x. So basically, we have our data set which has x, or x consists of x1, x2 up till xn, n number of features, and there is some prediction y, and we have to best estimate this function y based on our training data. So whatever, let's say this is the entire data set, using let's say 80% as our training data and 20% as test data. So on this 80%, whatever function that we are predicting, we have to best estimate that. And what we can do in order to do that, we train on this 80% data, and then we get some predicted function, we can say as the predicted function or the mapping function, because it won't be exact. So as the name suggests, that the function that we get after a machine learning model is being trained is a predicted function. There will be error always. Sorry. So this error is basically generalized in three forms. So the error will be always a summation of a bias, a variance, and there is something called as irreducible error. And as the name suggests, the irreducible error, we can't do anything about that. So we will not discuss about that error right now, because that is something that we cannot do anything. It will come in a, like, irrespective of whatever algorithm we use. So that's why we are not going to discuss anything about this, because nothing we can do about that. So whatever we can do is regarding bias and variance. So we'll discuss these two things in a thorough detail. So let's begin. So firstly, what is bias error? So what we can say, that bias, as the name suggests, is that whatever assumptions that we make to learn the function. So we'll, that's why I introduced a brief recap. So the target function or the predicted function y, in terms of input data x that we predict, we make some assumptions in order to predict that function, and that assumptions leads to some error which is called bias error. And if you didn't get this definition, I have some simplified definition here. So what is, it represents the error occurred due to wrong assumptions, right? Because assumptions might be wrong. We assume things because we need to make things simple. For example, data is assumed to be linear, but actually it is quadratic. So this leads to a biasness, that we are more biased towards linear data, even though data is quadratic, not that much quadratic, but yeah, data is quadratic, we can see that. But we are assuming that no, let's continue with the linear thing, and that can, because this, we are more biased towards linear thing, and that's why it is called bias, right? So what low bias means? Low bias means that less assumption about the form of the target function, so we assume less. That's why low bias, and this is what is good thing. But high bias is not a good thing, because it will be, there will be more assumptions, and assumptions are always wrong, right? So not always wrong, but might be wrong, because we assume always to simplify, and when we assume certain things to simplify, it means that we will not get, will never get the exact output that we want, so there will be always an error. So in general, low bias is a good thing, but high bias is not a good thing. So always we'll try to have low bias. Now let's discuss variance, and then we'll see why there is always a trade-off between bias and variance. So these are some algorithms. So decision tree, this DT is decision trees, KNNs, which is k nearest neighbors, and SVM. All these algorithms we already discussed. So these are low bias algorithms. You can verify this, and this is your task, that just like I have all the video lectures on decision tree, KNN, and SVM. So just go and verify that why they are called low bias, right? And these are high bias. So what is LR? LR is linear regression. This is linear discriminant analysis. This is something that we will discuss later on. And this is logistic regression, right? So why, what is this algorithm? This is really powerful algorithm, especially in NLP things. So we'll see that thing later on. But I'll say the abbreviation is linear discriminant analysis as of now, and this is having a high bias. Now let's continue with the variance. Now the second term is variance error. So what this represents, it represents the amount that the estimate of the target function will change if different training data was used. So if you didn't get, let me explain it in a different way, that let's say that there is my machine learning model M1. This is being trained on some training data D train. Let's say we have an entire data set D and it has D train and D test, and we train a model M1, any model, linear regression, anything, any model, just consider it as of now. Now let me train the model using some D train which is different, right? So let's say we have took 80% and 20%. So we trained on this 80%. Now let's take some different 80%. So because we are taking it D train and D test by random shuffling. So now let's say we will not take the same 80%, we'll take, after shuffling randomly, we'll take some other 80% and let's again train, and let's call that model M2. So if these two models changes significantly, because here the data is not changed significantly, because actual data set is D is the same, just we are taking some little bit other data from the actual data set, right? Sorry. So these two models, if they will differ significantly or the model changes significantly, then we can say that we have high variance, right? So this is the simplest explanation of variance or high variance. So that's why again I'm reading the definition, that it is the amount that the estimate of the target function nothing but our model, will change if the different training data was used, and that's what represents the variance. So what low variance suggests? It suggests the small changes to the estimate of the target function with the changes to the training data, and the same thing in case of high variance, we can say that it suggests the not small but large changes. So let me just write here large changes, and rest all is the same. So let's see the example of that as well. So again you will see that this were high bias model previously. Let me just compare that. Here you can see that linear regression, logistic regression and LDA were high bias model, whereas here you can see they are low variance. So always when variance is high, the bias will be low, and that's why we always call a bias variance trade-off. That was the topic of today's lecture. So this is your task that sorry, you need to verify why these models are low variance and why these models are high bias as written here, right? So this is your task that you have to verify based on the definition, that just train on the different model and see that how things are changing, and you can estimate about variance, correct? And footnote is that you can't quantitatively calculate that this is the variance this much, like let's say my variance is 10, you can't calculate, because we actually don't know the actual function, right? So because we always have some irreducible error as well, so this is not the thing that you can actually calculate, but yeah, you can get a brief idea that whether your model is high bias or high variance or anything else. So next is the trade-off. So the ultimate goal is always we need less error. So since the error contains three terms, bias, variance and irreducible error, so always we need low bias and low variance. And generally the linear machine learning algorithms like linear regression are always high bias and low variance, and the non-linear are having the high variance, then of course low bias. For example, KNN. So KNN is a low bias high variance model, and how you can verify, as I told you, that you have to just go with the definitions and see that what is happening. So now if my K will increase, so what KNN does, let me just recap it again, that let's say this is my training data set and these are two classes. So what KNN does, let's say we have a query point xq, and let's say we have k is 3nn. So let's say we got some query point xq here, and we have to classify whether this belongs to this red class or blue class. So what KNN will do, it will see the nearest 3 uh, data point, and will see that, take the majority vote, that nearest 2 are red, so this query point that we get belongs to the red class, right? This is what KNN do. So when we increase k, what will happen, that we'll see more number of neighbors, and if we have red as majority in our training data, then majority or most of the time will classify any given query point as red. So as the k increase, our bias increase. This is what I am explaining, that how you can check that what happens when k increases, bias increases. So any model, the parameter that you can tune, based on that you can either increase or decrease the bias, but we don't want the bias to be increased. And in order to control the bias variance trade-off, we always use regularization. And lasso and ridge regression, in regularization term, the lambda, we do the same, right? So we'll discuss thoroughly about regularization in a next video separately. I'm sorry for this coughing in between, but I'm a bit not well. So I hope you understood that what does this actually mean, the bias variance trade-off. So now we'll continue with our ensemble methods from the very next video. Thank you.